Hi, in this video I'm going to teach you the concept of compound interest. In my other video I discussed the concept of simple interest, and we'll start the discussion on compound interest by comparing it to the simple interest. Now in the simple interest, note that the concept is the simple interest is computed for the whole period one time. Okay, that is why when in my example before, if I invest 44,625 after 5 years under a rate of say 9%, then I will compute the interest based on the principal, the time, and the rate in just one computation, following the formula I equals P RT, and this is the interest that will be added to the principal amount. So how does a compound interest work? Suppose the same amount of money is invested and you want to know how much your money will grow after 5 years, but this is not under a simple interest, but they say the money will be compounded, say, quarterly, and they use the term compounded quarterly under, say, the interest of let's use this time just the same 9%. So the interest rate is 9%. Now the main difference of the simple interest to the compound interest is that it was mentioned that it will be compounded quarterly. So in concept, what is the meaning of compounded quarterly? In the simple interest, your money will grow based on the period after 5 years. So we simply get 44,000. So again, 44,625. We compute the 9%, and then we compute that under 5. Just one computation, and then that will be the interest. Now in the compounded quarterly, or say compounded semi-annually, there are different types. Okay, when it comes to compound interest, compounded quarterly means quarterly is referring to the number of times your money will change in a year. So quarterly, that means 4 times in a year, every 3 months. So the computation, if we will be following like the step by step, so first you want to know how much is your money after the first computation. So if we use 44,625, after 3 months, the first quarter, 44,625, we get 0.09, and then we multiply this by, well, it's just quarterly, so only 3 months, so that's 3 out of 12. The time is still over 12, or 0.25 of a year. So this will be equal to, so we just have to compute for the value. That's 44,625 times 0.09. 3 over 4 is 1/4, or we can just say times 3 over 12. And the interest is 1004.0625. So just after 3 months, your money is now from 44,625. It will grow already by 1004.0625. And since this is compounded, then the principal amount, which was just 44,625, will now become 45629.0625. So the money already changed after 3 months. And aside from that, when we go to the second quarter, because we just we were just computing for the first quarter, the first 3 months, this amount of 45,629.625 will become the new principal amount in concept. It's like if you use the formula now, we are no longer computing for the amount based on the 44,625, but under 45,629.0625. Okay? So suppose we go now to the next 3 months. Note, we are going to do this computation for the 5-year period, and we were just computing for the first quarter of the first year. So when we go to the second quarter, that's another 3 months, 3 out of 12 time. So the interest now is still PRT. So P, this is the effect of the compound interest. Your P is no longer 44,625. Your P is now changed to 45,629.0625. So 45,629.0625, and then times the same rate, 0.09, times another period, which is 3 over 12. Because you're doing it just for 1 quarter. You're computing it. Remember, compound interest, you compute for the value every time. Like if it says quarterly, then every quarter. Okay? And I want you to know the big difference now. We are computing the interest not based on 44,625, but on the new amount every time the money is being compounded. Okay? So for the second quarter alone, so expect that the value will change again. It will go higher. Okay? Now, you might be wondering, so are we going to do this for because we are compounding, or the money is being compounded quarterly. So that's 4 times in a year. 4 times in a year. So that means, and then 5 in 5 years, you have 4 times 5 equals 20 times that we will be computing for the value. Well, in concept, that's how it works, but we can simplify this by using a specific formula. The moment we recognize that it is a compound interest, okay, and this is where I will present it to you. Okay, so when we are considering compound interest, the formula, not just for the interest but the amount after a period of time. So if we say A is the amount, still P is the principal, the first money, okay, the money that you will invest. This is the principal amount. R is still the rate of interest. We introduce a new variable N. So this is the number of times the money is compounded. In a year. And then T is still the time in years. That is why in our example, I use 3 over 12, not just 3, because 3 is in months. 3 months in a year is 3 over 12, okay, or 0.25. So what will be the formula? The A, the amount, is the principal amount multiplied by 1 plus the rate of interest over N, the number of times the money is compounded in a year, and then raised to the product of N, this is the same N, and then the time. Okay? So to simplify our computation on the investment for an amount of 44,625 compounded quarterly with an interest of 9%, and we want to know how much will be the money after 5 years, we no longer do the step-by-step computation like how much is in the first quarter, second quarter, and so on. We just go straight to our formula and put the necessary values. So the amount after 5 years will be the amount you invested, the principal amount, 44,625, multiplied by 1 plus the rate 0.09 divided by the n. The n is the number of times in a year. Quarterly means 4 times in a year. Raised to n, that's still 4. And the time we want to see, or we want to know the amount of money after 5 years. So this setup, if you input this in the calculator, will give you the amount of the money after 5 years. Okay, so you can simplify further by writing this as still 0.09 divided by 4 and raised to 20. So if your calculator is a natural display calculator, then you can just input this directly. So if I do that, 44,625 multiplied to a group, I can use a parenthesis, 1 plus, then a fraction function, 0.09 divided by 4, and then I raised this, so there's also an exponent function in the calculator, raised to 20, and the money is now 69,637.72. So after 5 years, you can expect your money to grow now to 69,637.72. Okay, so note, from 44,625, your money is now 69,637.72. So the difference of these two values is the interest that you gain, the total interest that you gain from a compound interest after 5 years. And if you want to compute, so how much is the interest, you simply find the difference. So 69,637.72 minus 44,625. So when we subtract, so that's 69,637.72 minus 44,625, and you gain an interest of 25,012.72. So this is the interest earned. Okay, so that's the concept of compound interest. Okay, we no longer use a simple formula for the interest I equals PRT to know how much will be added to your principal amount, or the amount that you invested. So we simply use the new formula. A is equal to the principal amount times parenthesis 1 plus r over n parenthesis raised to nt. Okay, so how to know if you are going to use that formula? It will be specifically mentioned if the interest is under simple or compound. So when they say under simple interest, then you find the interest using the PRT. When they say compound interest, then to find the amount, you use the formula presented in this video. Okay, so I hope you understand now the basics of compound interest. In the more complex questions, like some situations will no longer just ask you to find the amount. They will not just ask for the amount, but sometimes the missing value will be the principal amount. Like they give you a future value. This is already the amount of the money after 5 years. Calculate how much was invested. So you are going back to the principal. So you're guessing, or you want to know how much was invested. Sometimes they ask you for the rate. Again, you manipulate the formula for the compound interest. Sometimes even for the number of times the amount is being compounded. Okay, but those types of problems will be discussed in a different video. Okay, but for now, this is the basic, or these are the basic concepts under the compound interest. Okay, so that's it.